Welcome students, and we are going to be looking at the distance formula today and why it's really just the Pythagorean theorem. I've got 2 points here on the plane, the point 21 and the point 64, and I want to find the distance between them. So I've given you the distance formula. So basically I'm taking, let's see if I can draw a straight line, kind of. I'm taking the distance between those 2 points, or the length of that line segment right there. I want to start off by just labeling my points x1, y1, and x2, y2. So I've got x2 is 6 minus x1, which is 2, plus, and then y2 is 4 minus y1, which is 1. Square that. Okay, and then you just simplify using PEMDAS. So I'm going to start with the parts in parentheses. 6 minus 2 is 4 squared, plus, and then my next parentheses, 4 minus 1 is 3 squared. And then I'll just go to the side here because I got space, why not? And then I'm going to go ahead and square next. So 4 squared is 16. And then, plus 3 squared is 9. And then I'm going to add the part in square root. So 16 plus 9 is 25. And then finally take the square root. 5. So that means the distance from this point to this point is 5. Now, if you look at this a different way, let's see if we can get that both on the screen. If you look at this a different way, you're actually just finding the hypotenuse of this right triangle right here. Look how beautifully I drew it. It's so pretty. But you can look at this as a right triangle. And this is, oops, go away. This is the hypotenuse. This might be your A side here. So from 2 to 6. I tried to circle the 2 and didn't. There you go. From 2 to 6, that's basically like your A side, and the distance there is 4. And then from 4 to 1, or 1 to 4, the distance there is 3, so it's like saying your B side is 3. And then this is your C side, which you're trying to find. So down here what I did is the Pythagorean theorem into the distance formula. So by kind of replacing the x1 and x2 with A, and the y2 and y1 with B, I've basically just turned one formula into the other. So when you're doing distance formula, you can, if you prefer, just draw out a right triangle and use the Pythagorean theorem instead, because you're going to get the same result because you're pretty much doing the same thing. So now I want to show you again what this might look like if we hadn't done distance formula at all and we had just looked at this as a right triangle. Kind of discussed that a little bit, but let's kind of start fresh and see if we can do it. So draw your right triangle. You could have drawn it up here also if you wanted. It doesn't have to be this way. It could have been upside down, and that would not make any difference. But let's just kind of stick with this version of the picture here. And if you're finding the length of the hypotenuse using the Pythagorean theorem, then you need to know the length of your A and B. So I'm just going to call this one A, I'm going to call this one B. And the distance here from 2 to 6 is 4. So my A is 4, so I'm going to plug that in. And then for my B, I have This is 1 to 4, so the distance from 1 to 4 is 1, 2, 3. I'll label all my values there. So the length of this side of the triangle is 3. And then I'm just going to do Pythagorean theorem like we did in the previous lesson. 4 squared is 16, 3 squared is 9, and that equals c squared. Then combine 16 and 9. And then finally take the square root of both sides. Square and square root cancel each other out. So that leaves me with c equals the square root of 25, which is 5. So that means my missing length is 5. And that's the same result that we got at the beginning with the distance formula, and that hopefully you got when you tried it yourself. That means you can really use whichever method you prefer. You can do Pythagorean theorem, or you can just use the, come on, scroll. There we go. Or you can just use the distance formula after labeling the points. So I've got another example here that you can try yourself. I have 2 more points, the points 0, -1 to the point 4, -3, and I want to find the distance between them. I would suggest trying it both ways on some scratch paper, seeing if you can do it, and then going ahead and continuing the video to try it yourself. Square root of 20, square root of 20. But those are the same. And then I'm just going to simplify it the same way, either 2 square root of 5 or 4.47. Your choice how you want to display that. Okay, so I'm going to offer virtual tutoring again. Just kind of keep an eye on Schoology updates. I will put links in those to the virtual tutoring times, and if the times I have don't work for you, please just respond and suggest a time that would work, because maybe that would work for some of your classmates as well. That's about it for now though. Let me know what questions you have, and thank you for watching.